While you can learn a lot by examining tables of data and creating aggregations, it's generally easier to identify and explore trends and relationships in your data by creating visualizations, variously referred to as graphs, plots, or charts. Here's a simple line chart that shows the values for daily revenue over a 2-week period. The chart plots the daily revenue figures as points and then joins the points to form a line that indicates the changes in values along the horizontal axis. We generally refer to the horizontal axis on a chart as the x-axis. In this case, the x-axis represents time in the form of the dates from the Lemonade sales dataset. You can also see that the chart includes an axis label identifying the axis and individual markers, sometimes called tick labels, for the date points. The vertical axis is usually referred to as the y-axis, and in this case it represents the revenue values. Again, it's indicated by an axis label and the labels for the values scale. The chart also includes a legend identifying what the line represents. This can be essential in charts that contain multiple fields or series. And finally, the chart also includes a title to make it clear what the visualization shows. It's generally good practice to include as many of these elements in your chart as necessary to make it obvious what the chart represents. Here's another common kind of chart. It's called a pie chart. Now, pie charts don't have x and y axes. Instead, they show categorized totals as proportions of the grand total. In this case, each colored pie slice represents total revenue for a day of the week. And you can see that 18% of Rosie's revenue was collected on a Sunday. Now, statisticians and data scientists don't often use pie charts, but they are very popular in business reports. This is a different way to show the same data. This is a bar chart, or in some tools it's called a column chart. Each bar along the x-axis represents a weekday, and the height of the bar up the y-axis indicates the revenue. Bar charts are often used to compare numeric values across categories. You can compare across multiple categorical variables by adding multiple series or conditions. In this case, there are now 2 bars for each weekday, one for the days on which Rosie charged 30 cents for lemonade, and one for the days on which she charged 50 cents. When you need to compare 2 numeric values, you can use a scatter plot like this. The plotted points show the intersection of the value for the field on the x-axis, in this case temperature, with the value for the field on the y-axis, in this case sales, for the same record. In this case, note that the plotted points form a diagonal trend, in which records that have the lowest temperature also have the lower sales, and conversely higher temperatures seem to coincide with higher sales.